So as I mentioned, today we are going to be reviewing factoring patterns. And anytime you have something that you need to factor, I want you to always start by looking for the GCF. So is there a GCF for this one that you see in front of you? ENC, do you see a GCF? What is it? And if we pull out XY, what will that leave for us, Maggie? How does that look? Thumbs up, thumbs down? Anything else we can still factor? Nope. In that case, we are finished. So you guys do the next one for practice. Is there a GCF here? If so, write it down, pull it out in front, write down what is left. And looks like most of you have just about stopped writing. Pete, did you see a GCF on this one? What did you see? Thumbs up, thumbs down. Is that what you have? Anything more we can do? Anything that needs to be changed? All right, great job. I see hands up all the way around the room. So always look for GCF first. Next factoring pattern that we're going to use will be a factoring pattern that we use when we have 4 terms. It is factoring by grouping. So here's an example. I have 4 terms in it. Callan, do you remember how factoring by grouping works? What's the vague part that you think you sort of remember?
You try to get all the blank just go together.
Okay, so we try to see if we've got some things that have something in common, like a greatest common factor on them. Help me out. Can I go ahead and do factoring by grouping just like this? Hint, yes. If I wanted to do factoring by grouping with it written just like this, does anybody remember how that one goes? I know it's been a long summer since you had to do this last. Okay, with grouping, you are going to take the first 2 and look for a GCF, and you are going to take the last 2 and look for a GCF. So, Zoe, what's the GCF for the first 2? And what's left? Now, what about the last 2? GCF for those last 2. Lydia. It's just 1. When we don't see anything else, there's always 1 or -1. So we're going to just say 1 and D plus F. Did we get lucky? Is there a parentheses that matches? So to finish it up, one of the parentheses is D plus F. That's like a giant GCF. If we would factor that out, we'd be left with E plus 1. Does not matter which parentheses is first. Now, I purposely typed this one the harder way so that we could talk about that 1 as a GCF. If I had written it, and this I think is more what Callan was thinking in the beginning there, DE plus D plus FE plus F, what would the GCF be here, Callan? And we'd be left with, and what would be the GCF, Evan, for this other part? And we would be left with, and then if we factored out the E plus 1, we'd be left with the D plus F, so we'd have exactly the same answer. Questions on that? Okay, next one, just like before, you do this grouping one on your papers, and we'll see what we are all coming up with. Hopefully, we all get the same thing on this. So you'll take the first 2, look for a GCF. You'll take the last 2, look for a GCF. Sharon, what'd you do with the first two? Excellent. And then for the last two, Mia. Mia A. Do I have two Mias in here? And we got matching parentheses, so final answer, one parentheses is a plus x, and the other one is 3 plus 2b. So grouping more or less coming back to you. Okay, next factoring pattern will be with just two terms, so a binomial. We're going to look at some special binomials that have a minus sign in between. But the first thing is something we can take a square root of. The second thing is something we can take a square root of. So how do we factor x squared minus y squared? Or if it's easier to think first, how do we factor x squared minus 16? Does anybody remember what we do with a difference of squares? Ashani? So for the factoring pattern for our formula list, it is indeed x plus y, x minus y. Does not matter if the minus is in the first or the second parentheses as long as we have one of each. So what would that mean for x squared minus 16? What would it look like? Mia S. Perfect. So let's do a few examples where we will end up using this. Anybody still writing this down? Okay, 16x squared y squared minus 4z to the fourth. What did I say a moment ago? I want you to always, 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 always look for first, Ryan. Do I have a GCF on this one? And what would it be? So just 4. So if we factor out 4, what will that leave us? Molly? Or Holly, I'm sorry. Minus z to the fourth. Okay, do I still have a GCF or did I really get it all out there? No more GCF, we have it all. 1, 2 terms, so it's a binomial. Do we have a minus sign in between? Can we take the square root of 4x squared y squared? And so, Jembe, what do we get? Can we take the square root of z to the fourth? Everybody, what do we get? So that means we keep the 4. It's still one of our factors. And we do one parentheses with a plus, one with a minus. The first one will start with the square root of 4x squared y squared, so we'll start with 2xy. I'll do my plus first. Square root of z to the fourth was z squared. This one's the same thing, except with a minus sign in between. So far, so good? Okay, next one's going to have something a little bit different. It doesn't say factor. It says solve. And it has equals something. So we want to make sure we understand the difference between factor and solve. If we just have one side of an equation and we do not know what it equals, we cannot come up with x equals numbers. We can only factor like we were doing on those other examples, GCF times parentheses, or parentheses times parentheses, something like that, but we do not get x equals numbers. If it says solve, then it must have an equal something. And now we need to end up with x equals number, x equals number. In order to solve by factoring, we must have equals 0. If it is not equal 0, we have to add or subtract and get everything on one side equals 0 before we can factor. So solve means get x equals numbers, and we've got to start with x equals 0. This one is good, so all we have to do is start factoring the left-hand side. What is the first method, Sydney, that we are always going to look for? Is there a GCF here? What is it? And Emma, what will that leave? And then we will write the equal 0 on every line so that we keep our work consistent. Have we finished factoring, or can we keep going? So we can keep going. So Matt, help me out. What do we do now? And we need to make sure that we don't forget the 2x. It is still a factor. So now we have one factor times a second factor times a third factor equals 0. When we have something completely factored like that, we can say the first factor could be 0, the second factor could be 0, the third factor could be 0. If we have a fourth or a fifth factor, however many we have, any one of them could be. Then we solve. So we would have for this one, x could be 0, x could be -3, x could be +3. For one this easy, this step right here, this line is optional. You could do that in mental math just looking at these factors. But if you ended up with a really strange factor for some reason, 3/7 x minus 5/13. Probably want to write some stuff down and do some steps for one like that because it's messier. Questions with that? Okay, example number 7. Am I going to have x equals numbers, or do I stop with parentheses on this one? Stop with parentheses. It says factor. We do not have equals a number. Do I have a GCF? No, nothing other than 1 or -1. Do I have 4 terms so I can factor by grouping? Do I have 2 terms? Do I have a minus sign in between them? So maybe it's difference of squares. Can I take square root of 1? Can I take square root of 16w to the 4th? So let's factor that, and we will have, what is the square root of 1? So both parentheses will start with a 1. One has a plus, one has a minus. What is root 16w to the 4th, everybody? Have we finished? Can we factor any more? Can I factor 1 plus 4w squared? No, it's got that plus sign in between it. Can I factor this one? Do I have 2 terms? Is it a difference of squares? Do I have a minus sign in between? Can I take the square root of 1? Can I take the square root of 4w squared? So we're going to keep the 1 plus 4w squared, but we are going to continue factoring the second parentheses. If I factor 1 minus 4w squared, what will I have for that? Hope? And now I am completely finished factoring, so that is what I have. So we're good with GCF, grouping, and difference of squares. Let's shift to, instead of 2 terms, binomials. What if we have 3 terms? First, one of the easier trinomials, because this one is 1x squared. 1 times x squared plus something times x plus something else. Surely somebody remembers how to factor this one. Does anybody remember what we need to do to factor this thing? Is it jumping?
Find 2 numbers that multiply what C would be, but add what B.
And so C was -28 and B was -33. And Mia S., did you figure out what our factors would actually be? So that's all I put in them? So the numbers would be -7 and +4. All we have to do is put those in, and that is our factoring. And so one last factoring one, and then we will jump in and start on some of our homework problems together. Let's do a harder one. And this is going to be harder for several reasons. I got to solve it. So do I stop with parentheses, or do I have to get x equals numbers? X equals numbers. Is it ready to go? So how do I need to change this one, E&C? So we need to factor 6x squared plus 7x minus 3 equals 0. Now that it's equal to 0, we can factor it. It is also harder because it is not a 1x squared problem like we just saw. It is something else times x squared, ax squared plus bx plus c. Does anybody in here remember what we have to do when it is ax squared plus bx plus c? Maggie, what are you thinking?
You have to factor to 6 times
So a times c, which is 6 times -3 or -18, and it still just adds to b, which is 7. So help me out here. Can anybody tell me two numbers that multiply to equal -18 and that add to equal +7? Blake? So 9 and -2. So here's what I see students did. So what we just did before, does that mean x, put in a +9 and put in a -2? No, that does not work. If we FOIL it, we get x squared. We don't get 6x squared. Last term would have to be -18, and we need it to be a -3. That does not work. We cannot just put those numbers in the parentheses. What must we do instead with this AC method? How do the 9 and the -2 help us out on one like this? Jen, do you remember? So we rewrite that middle term, and it does not matter if we do +9x minus 2x or -2x plus 9x. It works both ways. So now we keep the 6x squared, and we keep the -3, and we keep the equal 0. Now I have 4 terms. What do I do when I have 4 terms on a factoring problem? Everybody. Grouping. So let's put the first 2 together, and let's put the last 2 together, and let's see what we have. So Emily N., what's my GCF for the first 2? And what does that leave? What's my GCF for the last 2? Shane? Okay, I first look at it and I think, oh, just a 1 is all they've got. But if I try the +1, then I need a -2x, and it's not going to match. So what you said is exactly right. We try a -1 instead. -1 times 2x is -2x. -1 times +3 is -3. We do have the matching parentheses. So we have 3x minus 1. 2x plus 3 equals 0, which means x is +1/3, x is -3/2. We get that right? Does that look all right? Any questions with that? Right, then let me hand out your homework papers, and we will get started on some of those.